Good morning, good afternoon, and good evening, everyone. So today we're going to be continuing our exercises specifically on arc length and curvature. So here in our previous video, we did a little bit of, um, or no, we did a lot of arc length exercises, such as finding the length of the curve. Yeah, it's usually about finding the length of a curve. And then here's the different one, the the length of the curve of intersection. But again, it's still the length of a curve. So there's just some extra steps to finding that intersection curve. So yeah, now we're gonna move on to um, some exercises on curvature. So previously we discussed that curvature, well, there's a formula for curvature, and the intuitive definition is that curvature is how fast the direction changes given a curve, right? So we previously discussed that the curvature is how quickly the curve changes direction, right? Okay, so knowing that, let's proceed to do more exercises on curvature. So we're being asked to find the curvature of a vector function, power of t, which is in ijk format, t to the 6j plus, what's this, t to the 5, okay? And this is the same thing as 0, t to the 6, t to the 5. And the formula, which we previously defined, is some curvature k. Note that this is a space curve that we're dealing with. So we're going to use this formula. So the first derivative, or the tangent vector, we get the cross product of that alongside the second derivative. And then we get the magnitude. And then the denominator is the first derivative. We get that magnitude, and we cube that thing. Okay. So let's find r prime of t first, because that's the easiest. So derivative of 0 is 0. Derivative of t to the 6 is 65. Derivative of t to the 5th is 5t4. And then the second derivative is 0, 30, t to the 4th, 20, t to the 3rd. And then now we can find their cross product, or we can find the magnitude. Any is fine. Let's find the cross product. So we do a cross product here. This is in terms of ijk. So we just plot everything in. 0, 30t fourth. Okay. 20t cubed. Then here we would get, so we take out the I. So we get 6 times 20, 60 to the 5th times 20t to the 3rd. We get 20 times 6, so that's 120. T to the 8th. And then we subtract that to 30. 30t to the 4th times 5t to the 4th. And so we get 150. 150t to the 8th for my I. And then we subtract. Now we take out the j, so we get 0. 0j actually. So we get the 0 minus 0. And then we add again for k. So again, we get 0 minus 0 for my k. And so we actually just get 120 minus 150. So we get negative 30 t to the 8. So it's actually just this vector here. And then the rest is just 0. Okay, so that's my cross product. And I guess we can get the lengths now. So we can get the length of that vector. So let's quickly do that. So we get square root of each component plus 0 squared plus 0 squared. Well, this will give us, okay, maybe we can put it here. So here we get 30 times itself, so that's 900. Then t to the 8th times 2, so that's t to the 16. Can I simplify that? Can I get the square root of 900? Yes, I can. I get 30. Can I get the square root of this thing? Well, I can, so it's t to the 8th. So it's actually just 30 t to the 8th. Okay. Now, I want to get the magnitude of my first derivative. So again, another distance formula here. So that's going to be each component squared. So that's 65 squared. And then this is 5t4, square that thing. Then I can get, oh, I think I get a nice number here. This is 0, this is 36, t to the 10th. It's not nice when you're looking at square roots. This is 25, t to the 8th. So yeah, not exactly the number I'm expecting, but I can simplify this thing. I can factor out a t to the 8th. I guess let's do it to make it cleaner. So I'm going to factor out a t to the 8th. So this is going to give me 36t squared plus 25. And t to the 8th, I can just take it out. So this is going to be t to the 4th. And this is the same. Okay, and now I just put them all together. So my curvature for my general curvature for this case is my cross product. So this thing, 30t over 8. I divide that by this thing, and I put in a cube. So it's this thing. My magnitude of my first derivative, I cube it, and I can keep on simplifying. I can say this is t to the 12, and then this is 3 over 2. T squared. And I can still simplify t over 8. I can still simplify by factoring out a t to the 8th. So this would give me 30 and this is just d to the fourth. And so that would be my kind of my final answer here. Yeah, seems correct. Okay, let's do another curvature problem. So here we're being asked to consider uh, a vector function. And so this is 2t squared, comma, ln of t, comma, t ln of t, right? And we're being asked to find its curvature at a specific point. So at point 2, 0, 0. So the first thing we want to do is find curvature at general point. Then we can move on to specific cases, right? So let's think about it. Well, we need the formula. So we need to find its derivative. So this would give me 4t. This would give me 1 over t. This would give me, so the derivative of this thing is product rule. I can take the derivative of this. I add it. And I take the derivative of this thing. And so this will give me ln of t, because this is 1. This will give me 1 over t, right? So that will give me 1. Yeah, that's it. I have ln of t plus 1. And then what else can I do? Oh, now I need to find my second derivative. So here I get 4. Here I get um anyway, I can make this easier. Oh, I can do -1 maybe. I can do that. And I just have a negative t minus 1. So that's -2. And so it's actually just -1 over t squared. Now I can try to do this with a quotient rule, which I'm going to try real quick, see if it works. So low d high, so derivative of high, minus high, derivative of low over low squared. This will give me 0, because the derivative of this is 0. This will give me 1, so -1 over t squared. So either way, both work. So yes, this is -1 over t squared. And lastly, the derivative of this thing, we have 0 here. This one's 1 over t. And we're done. We got that. Now we want to get their cross products. So cross product of these two. This will give me 4t, 1 over t, ln t plus 1. This will give me 4, -1 over t squared, 1 over t. And now I can do some cross product here. So I can say I take out the 1, and then I do 1 over t times 1 over t. So that's 1 over t squared. I subtract that to this negative thing. So this thing times this thing. So well, it's gonna be a plus, right? So I'm gonna say plus this thing divided by t squared. And then that's my I. I subtracted so now I take out my j. I get 40 times 1 over t, so I get 4, right? If I multiply, I can cancel the t's, I get a 4. So it's actually just 4 minus this thing. So 4 ln, so 4 times this thing plus 4. Yeah, so that's my j. Then for my k, hope it's not long. When I take this out, I have, ooh, so I have this thing times this thing. So here I can take out my t, I get negative 4 over t. So I have minus 4 over t, subtract that to 4 over t. Oh, voila, I get 0. Oh, actually, I don't. Oh, no, I do. No, I don't. Because, yeah, 4 over t, I subtract. Yeah. So it's just, yeah. So can I simplify? Well, yes, I can simplify this one. So I get uh, ln of t plus 2 over t squared. That's my I. I subtract it to 4 plus 4. So that's 8 minus 4 ln of t. And then that's my j. Then I add it to negative 8 over t. And that's my k. And now I can just put them in vector form. So I have this thing as my x component. And then, so minus, and this one's a plus. So I'm going to switch the rows here. Now this is a positive, and then there's a negative. Then my other one is, well, the same thing. And that's my cross product. Now, I get the magnitude of that thing. So if I want to get the magnitude, well, I just do this. Double prime. And then this will give me, well, the distance. So I square that thing. So yeah, some long computations here. And I keep doing it. Okay. Can I simplify? Well, some of it is gonna be hard. Like this one. This one's really hard to simplify. Um, yeah, some of them are extra hard, but who knows? Yeah, I'm gonna keep it that way. Okay, before I mess up. And then lastly, now we want to find what was it? Oh, the magnitude of my first derivative. So let's do that. So this is going to be so what's my first derivative of this thing? And I just do a square root of each of that. So it's gonna be 4t squared. I add it to 1 over t squared. I add it again to ln t plus 1 squared. So again, another difficult thing to simplify. I could simplify the others a bit. but I don't think I need to. And now we have a general formula out of this. Okay, so if we want to find the point, at that point, we want to find the t value that will give us that point. So I want to find parameter that will give us 0.200, right? That's what we want to do. So the way to do that, well, we find t. So we use our position vector, which is this thing, and then we set it equal to its corresponding thing here. So we say t squared is equal to 2. That's true. We divide all of it. T squared is 1. T is plus minus 1. Now let's look at the other one. So ln of t is equal to 0. So we have ln of t is equal to 0. So t is e to the 0, which is 1. And then lastly, we look at t ln t equals 0. So t could be 0 or 1. So which one works? Well, from what we can see, t equals 1 is the common theme here. So that's what we're going to use. So knowing that t equals 1, then we want to find the curvature at 1. So we want to find k of 1. You're sure that's a k, right? If not, please correct me. And then we do a, what was the formula? Oh yeah, right. The magnitude. Yeah. And then we do, so this thing, the magnitude, we put ones in there, see what happens. Then we get that all over r prime, the magnitude of that, and we cube it. And this should give me some number. So let's say I can plug this in here. ln of 1 is 0, right? So I say 0 for ln of, what was it? I'm just calculating it at this point. So I plug in ones here for the t, so I get 0. So I get 2 uh, over 1. So that just gives me a 4, right? So here I get 4. Then I add that to, so here I plug in a 1 again. So that gives me a 0, right? And so I have negative 8 squared, so that gives me 64. And I do it again. I plug in the 1 here, so I get negative 8. So again, I get another 64. And then if I plug in the 1 in my r prime of 1, here I plug it in here, I get, so I get 4, I get 16. So let me just do this thing, and I cube it. So I get 16, I add. And then here I get 1, so 16 plus 1. And then here I get ln of t, so that's 0, 1, so that's just 1. And so from there I get 64 plus 64 plus 4, 132. Can I square that 132? Okay, maybe I can't. I hope I didn't mess it up. Hopefully not. Um, if I did, please correct me. This is 132. And then this is 16 plus 1 plus 1, that's 18. So I have square root of 18 cubed. Now, can I simplify? Because if I can simplify, that would be nice. So I get, okay, I actually get, can I do 132 divided by something? Okay, so I got 2 square root 33. So I can do that. What else? Here, maybe I get 3, because of the 9, 3 square root of 2. I get that. And now, yeah, that looks, I'm not sure. Because my reading gives me a different thing. Um, what's 18 to the power of 3 over 2? What is that? Okay, so it is, yeah, this is definitely wrong. Um, yeah, this is definitely wrong. Unless I really did mess up. Let me see if I got my first and second derivatives right. At least that. Okay, so I did get that. But somehow in the computation, I lost my way. Yeah. So maybe the technique here wasn't to do this. Maybe I should have just plugged it in immediately before even doing cross products and all that stuff. So maybe I should have just plugged it in, see where it leads me to. Oh, but then again, about the cross products. Yeah. So that one was, I don't know, but getting the cross product's fine. Because if I just plug in a 1, I get a corresponding vector. That one's easier to do instead of this one, right? So yeah, next time. But overall, the procedure was totally fine, right? Okay, let's actually try to do that in the next example. So here we're being asked to find curvature. Okay, the V did not appear nicely. Curvature of my vector function. So here I get 3t, I got t squared, I got t cubed, and it's telling me to get at the point, or at some point, and this is 3, 1, 1. So how do I do this? Well, I go ahead and do the formula, or I write the formula down, times r double prime, and then I get my magnitude, and I cube it, right? So my idea is I want to find, let's go ahead and find t immediately, actually. So I find the t that gives me that point. So find t. Let's just do that. So my 3t is equal to 3, right? So here t is 1. Let's try my next one. T squared here is equal to 1. So I get t equals -1, t equals 1. Then my other one, t cubed, is equal to 1. So here I just get t is equal to 1. Because if I put a negative, then that doesn't work. Yeah. Or another way to show that this works is to get t equals cube root of 1. And cube root of 1 is the same thing as 1 to the power of 1/3, right? And that'll just give me 1 exactly. That's a more precise way. But overall, the thing that works is t equals 1. So we're going to do that. Now, next thing we do is we find r prime and double prime. So let's do that. R prime is, well, this thing. So I get its derivative. So I get 3, 2t, 3t squared, right? And then my r double prime, well, I get 0 to 60. And then what do I do from here? Well, I could immediately plug it in. So I'm just going to plug it in. So r prime of 1. So here I get 3, 2, 3. And then for my r double prime of 1, I get 0, 2, 6. So it's easier, right? And then maybe, okay, now I have my formula. I got everything I need. Now I can compute. So I can find, or no, now I actually get their cross product. So maybe r prime 1 cross product with r double prime 1 is my, so here I get my cross products. So here it's easier because now I'm dealing with numbers, right? So here I get, I take out my I, so I get 12 minus 6. I take out my j, I get 18 minus 0. I take out my k, I get 6 minus 0. And so this just gives me the vector 6, negative 18, positive 6, right? And then from here, I just, well, I get the length. So here we're now treating it like it's a step-by-step process. So I get its length, so I get 6 squared plus negative 18 squared, or 18 squared is fine. Then there's 6 squared here. And this will just give me 36 plus 36, 72, 18 squared. So 72 plus 18 squared. That gives me square root 396. Now can I, okay, cool. I guess I leave it at that. And then from there, now I can, oh, I can also get my magnitude and cube it. So I can say, oh, so my magnitude cube. So here I get, what is this? Square root of my 323. So 3 squared plus 2 squared. Okay, I put 3 there. 2 squared plus 3 squared again. And I cube all of that. Then again, I do it. So I do 9 plus 9 plus 4. 18 plus 4, 22. Right? Can I simplify that? I don't think so. No. So I got 22 to the power of 3 halves. Right? Then from there, I can just, I got it. So now I can just say my curvature at 1 is just this thing. So okay, I got a different one, but I guess it's fine. Let me see. 3 square root of 2. Could I have divided it by a 4 maybe? Maybe. Ooh, so I could have said, okay, maybe I can simplify just so that fits the exact thing. So I got 4, I get 99. I could divide that, right, by 9. So again, another thing I could divide it with. But at this point here, I'm just trying to simplify. Oh wait, you know how I can prove this works? I can try to get an approximation of what exactly this is. Square root of 396. Okay, I divide it by 22 to the power of 3 halves. And I get something along 192 maybe. 0.28. And then maybe I can try it here. 3 square root 2 divided by. So yeah, I do get the same thing. Yeah. So this is exactly the same as 3 square root 2 over 22. It's the same thing. Yeah. Okay. So that's it for curvatures. Yeah. Let's try to move towards maybe uh by normal and binormal vectors so that we can get that one quickly. Uh yeah, I'm I would do that though. Let me let me pull up that. Although I'm also not sure if this is gonna be on the test, but I hope it is or it's not. I'm not super sure. So I'm just gonna do it. Um then we also have this idea of torsion, which again I'm not super sure if it's gonna be included. Hmm. Okay. I'm still trying to figure out what my next steps are gonna be. uh, let me just see my recordings. Yeah, because I've covered. Okay, let me just check. If it doesn't cover binormal and normal vectors, I might as well just go through practice exams. Then, yeah. Uh, but yeah, I'm not super sure. Row vectors length, equilateral parallelogram, tangent collide, 13.3. Uh, Curvature, distance, shape, vector, facts, arc length, tangent line, curvature, vectors, and points. So maybe I might just go over. Yeah, I'm not super confident because it also wasn't in the exercises when I did this. There weren't any normal and binormal vectors, so maybe it's not included. But yeah, we'll see. Yeah, because I also wanna do problems on the previous lessons. Uh, okay, here's what I'm gonna do. Um, I'm gonna ask general. Okay, okay, let me question. Yeah. Oh, maybe a post. Okay, title general. Okay, don't know why I can't see where I can type this thing. Select a subcategory. Core. I don't know, lectures maybe. Okay, I'm gonna ask. But for now, okay, maybe I'm not gonna talk about because I'm not super sure. Um, Normal and binormal vectors. Okay, but yeah, for now I'm just gonna um, yeah, because we didn't talk about any of that. So yeah. Okay, so here's what I'm gonna do. I'm gonna end the video here. And then for the next couple of videos, I'm gonna post more on exercises for since I'm gonna be having my exams. So yeah, I'm just gonna go through a rough overview of each of the items that will be covered in the exam. So yeah, I hope you guys enjoyed, maybe learned something from curvatures. It's honestly a pretty interesting topic if you think about it, because well, you're analyzing a curve, right? And so in the space curve, at each point, you can see or you can measure how fast its direction is changing. And the measurement that will be used to measure, the measurement that will be used to measure, well, a mathematical tool used to measure that thing, that speed or that rate of direction changing, well, is the curvature. And we have a formula to do that. So yeah, honestly, just some pretty fun, interesting stuff to be honest. If it were me, honestly, if the course wasn't quick or it wasn't fast paced, maybe I would have done a couple more examples, maybe even IRL applications. I don't know, but yeah, fun stuff. Really, really fun and interesting stuff. Okay, before I yap eternally, before I yap, I hope you guys enjoyed, and I'll see you all in the next one.